You've just received test 2 back. Hopefully you've already seen your marks, so you're not emotionally processing this, just on a sort of logical level. The answers for test 2 are up now. My apologies, I was so slow putting up the answers for test 1. The test 2 answers are already up on Quarkus. They're on the main page, just scroll all the way down. So it wouldn't be a terrible idea to check the answers before you ask me why you did or did not get a mark. That would be an okay thing to do, I would recommend. Okay. The average was once again quite high. It was 78. Here's the distribution of the final scores. So the number of students is the vertical axis and the scores are the horizontal axis. You can see it's a kind of bimodal, but more or less a bell curve-ish. Symbolization scores were the lower one. I think the average there was 72, something like that. More of a bell curvy sort of thing. So exactly as people reported, the symbolization seems to have been harder than the derivation. The derivation scores were not at all bell curvy. You guys destroyed the derivations, just absolutely cleaned them out on average. Not to say that if you personally didn't, but you as a group demolished these derivations. So, well done. I'm really happy to see these results, by the way. I'm a little nervous because the average is super high, but I'm also really happy because that means that you're, on average as a group, really getting this stuff, which is exciting for me. So, any questions about the test? Huh? Okay. So, if you're listening to this on recording, I'll have these tests in my office. You're welcome to pick them up at any time. Those of you sitting in front of me, obviously, that doesn't apply to you. Okay. So we've only got a few more things. So let's do this. First we're going to do multi-place invalidities, which is pretty much the same as single place, but more. And then we're going to do expansions. And before we do examples of multi-place invalidities, I'm going to go through the steps for expansions because the expansion stuff really helps deal with the multi-place invalidity stuff, I find. So, remember in single-place invalidities, we were just assigning objects to predicates. We had an open bracket for the F, and we were just sort of sticking objects in F. Now, clearly, we can't say of a multi-place predicate that it applies to one object. It's got to be, of course, a pair of objects. That's what a multi-place predicate says. It's like a relation, typically. So here's an example. Let's say that the F predicate is a two-place predicate, A likes B. We've got two sentences. We've got a premise and a conclusion. For all x, there exists a y such that F likes, x likes y. And there exists a y such that for all x, x likes y. So the first one says, everyone likes some generic person. And the second one says, there exists a specific person who everyone likes. So far, so good. This is just sort of setting up the situation. And we've got a universe of discourse with exactly 3 objects. They all happen to be people, Amy, Lee, and Vic, right? So here's the setup, and we're going to try to do an invalidity on this thing. And of course, we can't just say that F applies to Amy or Lee or Vic. That doesn't make any sense anymore. We have to say that the F predicate applies, for example, if Amy likes Vic, then we'd have to say F, Amy, Vic. Or if Vic likes Amy, we'd have to say F, Vic, Amy, right? So we need to put pairs of objects in these things. We need to do what's called ordered pairs. We'll put these in these little triangular brackets. So here are some things. So suppose we fill it out in this following way. F says Amy likes Lee. Sorry, the first one, Amy likes Lee, so there's an ordered pair. Second one, Lee likes Vic. And the third one, Vic likes Amy. Okay, so filling in which objects the predicates apply to is no longer a matter of just sticking one object in. It's a matter of sticking an ordered pair where the order matters into the predicates. That's how we're going to build models for multiplace. And once again, we're going to simplify this for ourselves. We're not going to, when you're doing invalidities, I'm never going to ask you about like stuff with content. I'm going to give you something like the following. There exists, for all x, there exists a y such that f x y. Therefore, there exists a y such that for all x, f x y. And then a universe of, so then you'll generate for me a universe of discourse and then some set of ordered pairs. that make the argument invalid.
Quick question.
Yeah.
When we're doing questions like this, how do we know how much the universe is?
Yeah.
Logic 2010, how do we know we start with 4?
Yeah. So when you're doing, it's a good question. How do you know how many objects the universe has? And what I'm going to recommend is that you slowly build up your universe of discourse. So start with just 0, which is one object, confusingly. Start with just one object, and then see if it works. And if it doesn't work, add an object. See if it works. And if it doesn't work, add an object. So slowly build up. You kind of make things maybe more complicated for yourself than you strictly speaking need to. If you start with 15 objects, that's too much thinking. You don't want to do all that much thinking in the middle of an exam or whatever. Yeah. Right. And now that we're in multiplace, so I'm not going to do this to you, but there's the logical possibility that you could need an infinite universe of discourse, and a universe with an infinity of objects. I'm not going to give you any questions that require an infinity of objects. It's going to be 2 or 3. Yeah.
For the F predicate,
Yeah.
why do you list all 3 potential pairings?
So that isn't even all of the potential pairings. Those are just some that we filled out. So I didn't list, for example, 1, 0, or 0, 2. So there's way more possible pairings. What this says is, so these are things that the F predicate applies to, and the thing it applies to are these pairs. And if I left out a pair, then it doesn't apply to the left out pair. So that's just like before when we said the F predicate applies to, if it was a one-place predicate, it applies to 0 and 1, but maybe not 2. We just write 0 and 1. Here, it applies to pairs of things, and we've picked out 3 pairs of things that I think this makes this argument invalid. Does it make this argument invalid? I can't recall. I think I did such that it would make this argument invalid. So does this make the first thing true? So for all things x, there exists some y such that fxy. So we say for anything that you can plug into the x part of that two-place predicate, that is 0, 1, or 2, is there something that it stands in the y relation to? So that seems right? So we've got 0 standing in the f relation to something, 1. We've got 1 standing in the f relation to something, 2. And we've got 2 standing in the f relation to something, 0. So there, for all x's, for anything that you can plug into this part, there's at least one thing, there exists a y, such that you can say that x stands in that f relation to it. So the premise is true. Good. Now, is the conclusion true? There exists at least one y such that every x stands in the f relation to it. Okay, we're going to learn a technique later this class that makes this less, if this is a bit like, so there exists at least one y such that any x stands in the f relation to it. So is there anything that you can plug into the y slot, given these pairs, given we're saying the f relation applies to these pairs, is there anything that you can plug into the y slot such that every possible x stands in the f relation to it? I think no. So we're looking for a specific y, a specific thing here, such that all possible x's stand in the f relation to it. So, well, we've got all 3 of these things in the y relation. So does 1 stand? So if we plug in 1 for this y, so here's what we're doing. We're taking these things and plugging them into the variable. So if we plug 1 in for the y, can you say that for every x, 0, 1, 1, 1, 2, 1? No. These are the only pairs that we're saying the f relation applies to, and it's not the case. So if you plug in 0 here in the right-hand part of this, it's not the case that there's something that for all of the x's, we've got this ordered pair in our predicate, right? So for 0, we've got 2, right? So if we say, stick 0 in here, then there's at least one thing that stands in the F relation to 0, but not everything. Same thing with 1. Not everything stands in the F relation to 1, or X, so you can't plug in any X, and the same thing for 2. Okay. So what we've got here is an invalidity. We've got a set of ordered pairs such that the premise comes out as true, we're happy with that, and the conclusion comes out as false, because we can't, to make this conclusion true, we would need it to be the case that there's at least one thing that you can stick in the right-hand part of that relation that within the F predicate you can find all of the things that you could potentially stick in the left-hand side. At least one thing in the right hand such that all things stand in the left hand stand in that relation. And that's not true. Okay. Okay, so that's the basic idea of multiplace invalidities. We've got no longer objects satisfying these predicates, but pairs satisfying these predicates. Okay, so if that was a bit hectic, if that was a bit like I'm not really sure what's going on and this is weird and uncomfortable and I don't like it, here's something that makes this easier to deal with. Expansions. And this is the last skill in the course, so enjoy this final skill that we're going to do. Solving these invalidities, and especially complicated multiplace invalidities, can be hard. It's hard to think, well, how would I have come up with that? So if looking at this, you think, how would I, so it's going to be I'm going to give you an argument like this, and it's going to be your job to come up with the universe of discourse and which objects get plugged into it. And if you're asking yourself, how am I going to do that? Here's a recommendation. Either you just see the answer because you're got the math chops for it, or you do this thing, which is an expansion. So given a universe of discourse, we can rewrite quantified sentences into sentences with no quantifiers. That's what an expansion is. It's when you take a sentence with quantifiers and you rewrite it into a much longer and more complicated sentence that nonetheless has no quantifiers in it. And then we're going to use that expanded sentence to build our invalidities. So that's the plan here. So recall when I explained universals, I told you the following. I said a universal says that the sentence inside the scope of the quantifier could be applied to any object. So in a sense, the universal is true if a series of conjunctions are all true. So if I say for all x, fx, there's a sense in which what that actually says is if fa, then ga, and if fb, then gb, and if fc, then gc, and so on for every single object in the universe. Recall that that's how I sort of explained how the universal quantifier works. Similarly, existentials say that at least one object satisfies the sentence inside, and we can symbolize this with a series of disjunctions. So as I explained how the existential works, it's something like this. If I say there exists some x such that hx and jx, what I'm really saying is ha and ja or hb and jb or hc and jc or and so on and so on and so on. Right? So that existential is true if there exists at least one thing. So just like any disjunction is true if any of the disjuncts are true, the existential is true if you can find at least one substitution on which it comes out as true. So that was the meaning of the universal and the existential quantifier. And knowing this, we're going to learn right now a technique for rewriting these quantified sentences without the quantifiers. And if your universe of discourse is the universe, this is going to be very tedious for you, right? Because you're going to have to write down practically an infinite number of things. But if you've got a small universe of discourse, then it becomes possible to actually do this. So, given a reasonably small universe of discourse, we can write out these expansions so we can eliminate the quantifiers entirely. Okay, here's what this looks like. So, Given the universe of discourse 0, 1, and 2, and the universally quantified sentence, if fx then gx, for all x, if fx then gx, we can rewrite that as if f0 then g0, and if f1 then g1, and if f2 then g2. So given this universe of discourse, the first sentence is exactly equivalent to the second sentence. And we're kind of breaking our rules. So up until now, I've never said it's okay to put in a number for where the subject of the thing is. Now that's okay. So we're gonna allow, in these expansions, it doesn't have to be a letter. We're just sticking in the numbers. Yeah. So this says the first conjunct here says, if the object 0 has the f property, then the object 0 has the g property, and 1 f. Yeah. We get that? Is it clear what this bottom sentence is supposed to be saying, I guess is the question. Like, the universal said, for anything that you stick in for x, this conditional is going to be true. And then this expansion says, sticking in 0 for x, and sticking in 1 for x, and sticking in 2 for x. Those have all got to be true in order for the universal to be true. Yeah? Okay. Okay. And similarly, with an existential, given this universe of discourse, given 0, 1, 2, there exists an x such that hx and jx gets expanded to a series of disjunctions. So either it's the case that 0 has the h property and the j property, or 1 has the h property and the j property, or 2 has the h property and the j property. Okay. Okay, so these are the simplest expansions you'll see. There's going to be more. It'll be more. Hang on. But quickly, any questions at this point? Okay. It is not yet. I haven't yet explained how this is any good to us at all, but it gets slightly more complicated when you've got more than one quantifier in the sentence. So let's learn the technique now for dealing with sentences with more than one quantifier in them. And the technique is basically you're going to have to do this in steps. There's going to be like a layered process of getting from one, and you just deal with one quantifier at a time. That's going to be the strategy. There's a lot of, you'll see. So here's 2 steps to get to. So the first sentence, the sentence at the very top, has 2 quantifiers in it. You're going to have to expand it in 2 steps. So the first step, I'm expanding. I'm going to start from the outside and work my way in. There's no logical reason why you have to do one or the other. That's my preferred way of doing it. So I'm starting with the existential. And I'm saying, so when you expand an existential, what you're doing is saying, and for my universe of discourse, I've just got 2 objects here. So I'm going to expand the existential into this disjunction, either, and just replace. So on the left-hand side, I've replaced the x's with 0s, and on the right-hand side, I've replaced the x's with 1s. See that? And then the quantifiers just drop away. Yeah? So from the top to the middle stage, I've eliminated the existential quantifier by creating this disjunction. Now, in the middle there, the major connective of that sentence is the or. And that's going to stay true when we do the second step. See, on the third line here, the major connective is still the or. We're expanding, so we expanded the existential first, and then from the second line to the third line, we're expanding the universal. And the universal kind of expands from within these sentences. They blow up inside the sentence. Yeah?
In the second step,
Yeah.
why do you need a universe that has at least 2 things in it already?
Well, you don't need it. But if I'd done just 1, then it would have been a boring expansion. You wouldn't be able to see the steps. And if I'd done 3, I would have run out of room on the slide. So very practical reasons for choosing a universe of discourse with just 2 objects. If I'd had a universe of discourse with 3 objects, then the second line would be if G0, then this thing, or if G1, or if G2, and so on. Well, no, I'm trying to teach you how to do it, so I need it to be at least minimally I needed this level of complication in order to show you the steps. Yeah. Purely pedagogical reasons. Yeah. Okay. So, from the first step to the second step, we don't touch the y variable. We just leave it as a universal. We leave it as a universally quantified sentence embedded within the larger sentence. And from going from the second step to the third step, we're expanding within. So for all y, f0y becomes f00 and f01. So on the left-hand side here of this disjunction on the third line, that universal becomes f00 and f01. And we're just saying, we're just making a conjunction because universals turn into conjunctions. And for everything in the universe, we're substituting it in for y. So on the left, y becomes 0. On the right, y becomes 1. Yeah? So from within that sentence, the universal gets expanded. And it's still, so the left conjunct here, or the left disjunct here, is still the major connective is a conditional, right? So we haven't changed the basic structure of that sentence. We've just said we just keep everything the same and replace the universal with this series of conjunctions that apply to every object, substituting in every object in the universe of discourse for the variable. And then we do the same thing on the right, exact same thing. So, but instead of having on the left here, we had 1 or 0 in the left-hand side of the f predicate. Now we have 1. So it works out as slightly different. So if G1, then F01 and F11. Okay, so we're expanding those universals within those sentences. So for each of those each of those disjuncts, the conditional is still the conditional is still the major connective, and for the sentence as a whole, the disjunction is still the major connective. Yeah? Okay. And it's still not obvious how we're going to use this. I mean, I'm showing you this, and I still haven't shown you how it turns into a skill. Okay. But one last thing. So I'm going to basically, the rest of this lecture, I'm going to do examples. I have one last thing I want to show you. I can finally explain to you why the order of the operators makes the thing about generics and specifics make sense. So here's why that's a thing. Given the way that we expand these sentences, you get differences by having the order of the operators be different. So here's a set of sentences. So A is a story, B is a twist, and C is A has B. So the first sentence there says, every story has some generic twist. So for every story there's at least one twist in that story. That story has at least one twist, but it's a generic twist. We're not saying it's all the same twist in that first sentence. We're just saying there's at least one twist. And the second sentence says, there's some specific twist that every single story has. It was always the butler that did it. In every single story in the universe, it was always the butler that did the murder, okay? Neither of those are sensible sentences, but you get the difference between the scope of the universal and the existential, and how these are saying different things, and it's saying something in the first one about generic twists, and in the second one about specific twists. And when I presented this to you, I'm just like, because I said so, just accept it. You've got stuff to do, don't argue. But here is a reason why that makes sense. So here's how you'd expand that first sentence. You'd say, for all, so the universal, we'll do the universal first. I mean, it works out the same way whether you do the universal or the existential first, but working our way from the outside in, the universal gets eliminated and the whole thing gets turned into a pair of conjunctions. Once again, I'm assuming a universe of discourse with only two things in it, because this would get really long and complicated if I didn't. So in the first one, the universal gets eliminated, and the whole sentence in the second line there is a conjunction. We're saying this is true and this is true. And in the third line, we've expanded the existential, and the existential expands into disjunctions, but the whole sentence is still a conjunction, right? The claim is still about all things. Or the claim is still is only true, the third sentence is only true if both halves of it are true. Yeah? So now I want to show you the difference between that and the other reading. So here's the other one. There exists a y, so this is where there's some specific twist in every story. Now the whole sentence is a disjunction. Now the whole sentence is a disjunction now, and it's true if either of its conjuncts are true. So there exists at least something that's a twist, and every story has it. Yeah? So the difference between something being generic and being specific can be cashed out in these terms. That is, whether the expanded sentence, the whole expanded sentence is a disjunction or a conjunction. And the order of the quantifiers determines whether the major connective of the expanded sentence is itself, does it all have to be true, or does it just have to be true of one thing? Yeah?
So if it's generic, it's a conjunction, and if it's specific, it's a disjunction?
That's right. That's right. You're saying there's one specific thing such that blah, blah, blah. Then it's, what you're saying is, you don't have to find, it doesn't have to be the case that a bunch of objects satisfy it. It's just like there's at least one thing such that the following conditions hold. Yeah. Okay. I don't know if that helped at all. Maybe. But let's do some examples, which I hope will actually help. So, right. So let's start a bit slow here. All right. So let's do this with the expansion method. Let's try it. Because I'd like to demonstrate it for you, and it also helps me to solve these things. I find the expansion method, you'll see once we've done the expansion, figuring out the invalidity is much more mechanical. It's not like 100% straightforward, but it's easier. It's easier than just sort of like seeing the answer. So let's do it that way. The nice thing about doing an expansion on this is that both this premise and this premise are not quantified. There's no quantifiers in either of these. So we don't have to do anything fancy to get these expanded. These are already expanded. Expansions just eliminate quantifiers, so we don't have to do anything about any of that. So let's just expand this first premise. All right, so it's a universal. Okay, so we're also going to, so you have to define your universal discourse. Let's just do two objects right now, and if that works for us, then we're off to the races. It is going to work for us, by the way. Oh, does it? Oh, no, it doesn't. Ugh. All right, we're going to do this. We'll do it too. All right. Okay, so we got a universal discourse with three objects, 0, 1, and 2. Yeah?
How did you find out that there's three objects?
I looked at my answer. Yeah. I cheated. Yeah. Sorry. Okay, so we got a premise with two quantifiers in it, and I'm going to start my standard way, start from the outside in. So first we're going to expand the universal. So this thing is going to turn into, because we've got three objects, it's going to turn into three things set up in a conjunction. So, and we're just going to start by replacing all the x's with zeros. If f0, then there exists a y such that r0 y. Yeah? And if f1, then there exists a y such that r1y. And if f2, then there exists a y such that r2y. Okay. Yes, it should be bidirectional. Thank you. Yeah. Okay. Okay, so that's step one of our expansion. Now we're going to expand the existentials. Let's do them one at a time. So this is going to expand to three things. So if F0, biconditional, and then keep in mind that when you're expanding something within the sentence, it never changes what the main connective of the sentence is. So this biconditional is still going to be the main connective, and then there's just going to be three things in a disjunction here. So either R00 or R01 or R02. So that's this thing expanded, bracket, and I'm going to skip to the next line to make this legible. Now I'm going to expand this thing, F1, biconditional, R, and it's going to be very similar. It's just that now I've got 1 here, so R01, so replacing the Y for all the objects in the universe, or R11 or R12, and F2, biconditional, R20 or R21 or R22. Okay. So this thing is premise 1 expanded. Yeah?
Why do you expand 3 times and doesn't need 2 for this variable?
Because there's 3 objects. So that's like, so I expanded 3 times. Yeah, I expanded 3 times because there's 3 objects.
What's the third?
0, 1, and 2.
Sorry, where does the 0, 1, and 2 come from?
That's my universe of discourse, and I just sort of like,
So you're given that?
well, I gave myself that. We could have done, so if we're doing an expansion on the exam, I'll tell you how many to start with. So yes, you'll be given that. If I say do an expansion on this, then you'll be given the universe of discourse. Yeah. If you were just working this out raw, like if it wasn't in a kind of training environment, they wouldn't be given the universe of discourse. You just have to try it with 2 objects, find that you can't solve it, and then try it with 3 objects. So it's a guess and check process, but let's not do that right now, yeah? So, okay, so we've got our premise 1. So this sentence says, given this universe of discourse, this big weird conjunction is the same as this thing. Okay, so now we've done an expansion. Now let's try to use this expansion to do the invalidity. So this is just the same skills as before, but instead of trying to like mentally work through the quantified sentences, we can just work through this sentence without the quantifier in it. All right, so that's what we're going to do. Is it okay if I erase this second step here? Okay, just for visual clarity, we don't want to get like overwhelmed here. I'll rewrite my universe of discourse. 0, 1, 2. Okay, so now the project is try to figure out what falls under the F predicate, the R predicate, and what these names apply to, in such a way that we make these 2 premises true and the conclusion false. Yeah? Okay, so when you're doing expansions, maybe the way to go about this is just to write out all the possibilities. So, and just build yourself a little chart. F0, F1, F2, and then we've got the R predicate. So R01, sorry, R00, R01, R11, R02. Oh man, there's going to be a lot here. All right. Oh well. There's going to be like 8, aren't there? 3, 4, 0. I should have done this more systematically. Who knows how to count in trinary? 0, 2. And then R1, 0, R1, 1, R1, 2. Excuse me. It's so easy. Look how easy it is. Okay. R2, 1, and R2, 2. I was really hoping this only had 2 objects in the universe of discourse, because that would have made it easier. But so then the thing is just to say whether each of these are true or false. So each of these are potential assignments of objects to predicates, and these are all of the potential assignments of objects and pairs of objects to our predicates. That's what we've just written down now. And the goal is just to fill this out in a way that just fill this out in a way that makes the premises true and the conclusion false. Okay, so we're going to start by asking ourselves what would make premise 1 true. Okay, so what makes premise 1 true? Well, it's a series of conjunctions, right? The whole thing is this and this and this. So what we need to do is make the whole thing, we have to make all 3 of these things true, right? Yeah? Okay, so we just go step by step. If F0 is true, then all this has to be true. If F1 is true, all this has to be true. If F2 is true, all this has to be true. So currently, we've placed none of these as true. Let's suppose if they all default to false, then premise 1 comes out as true already, right? Because if F0 is false and all this is false, then it's true. And if F1 is false and all this is false, then it's true. And F2 is false, all this is false, then it's true. So far, premise 1 is true. Hooray! Okay, now we have to make premise 2 true and the conclusion false. So I imagine it's going to get more complicated when we try to do that, right? So let's try it. We need to say something is A and something is B. A is the name for something, and B is the name for something. So let's say A is the name for 0, and B is the name for 1. What is the deep principled reason on which I chose that? Nothing. I'm guessing and checking. Yeah? I'm guessing and checking. So is FA and FB true? Well, currently F is not true of anything, so these are both false. So we need to make these both true in order to make this premise true. So that means F0 has to be true and F1 has to be true. Yeah? Okay. However, now we've made premise 1 false because we relied on the sort of trivial truth of this stuff in order to make it true. So let's just check on our conclusion to see if it's true or false right now. So R stands in the A relation to B. Yeah, so because I haven't put anything in the R relation, this comes out as false automatically. So that's good. So far so good, but we're going to have to make premise 1 true where the work is probably going to be given that we've made F0 true and F1 true. So we need all 3 of these things to be true in order for premise 1 to be true. We need all 3 of them to be true. Currently, F2 is still trivially true because there's nothing under F2. So if these are all false and this is false, that's fine. But to make F0 true, so to make this first conjunct true, given that F0 is true, then at least one of these things needs to be true, right? So the biconditional says this thing has the same truth value as this whole thing. So this is currently true. So I need this whole thing to come out as true. And if it's a series of disjuncts, that means I need at least one of these things to come out as to be true, right? So I need at least one of these things. Let's pick this one. I'm going to make, for no reason at all, R02 true. Okay? So fine. Now this whole thing comes out as true. Similarly, I need this thing to come out as true. So I'll just make R12 true. Okay? So because this half is true if this or this or this is true, making R12 true makes this whole, given that F1 is true, this whole thing comes out as true. So this conjunct is true, this conjunct is true, and because F2 is false, we've got nothing under R20, R21, or R22, this one also comes out as true. Okay. So far, so good. Now, let's just check. So we made premise 1 true. I think we made premise 2 true. Let's see if we made the conclusion accidentally true or whether it's still false. If it's still false, I think we win. I think we've got it. So RAB or RBA. Both of these have to be false for this to come out as false. So we need this both conjuncts to be false. So R01, is R01 false? Yes, hooray. R10, is R10 false? Yes, hooray. Okay, so now we've got it. Now we've got the extension of our F predicate is 0 and 1, and the extension of our R predicate is the ordered pair 0 and 2, and the ordered pair 1, 2. And we've done it. Yeah?
Couldn't you have done that with the universe of discourse of only 2? 0, 0, 1, 1.
0, 0, 1, 1.
So if you made 0, 0 true, 1, 1 true, and the other two false, it's still false.
Let's see. 0, 0. So that would mean that we don't have to worry about this sentence.
Cut off the last disjunct.
And we cut off this thing. So, okay, so we still need F0 and F1 to be true. And now we've got 0, 0 is true, 0, 1 is true. And now, does 0, 1 come out as true? Yes, and yes. Oh, we could have done it with, wow, okay, good. So all that for naught. Not all that for naught. Okay. Before we take a break, questions? Yeah?
I don't understand how you got the last part, the R02.
Sorry.
Did you just assume that they were false?
R0, wait, oh, how did I get the conclusion? Say, what do you mean by the last part?
The conclusion.
The conclusion.
That they were false.
I didn't assume that they were false. Sorry, unless what you mean, so I'm assigning true to things, and if I haven't put a T under it, then assume it's false. Just in the same way that if I don't write, so if I didn't write 2 under the F predicate, then it's false. F is not true of 2. Right? So we're start from assuming that there's no object that satisfies the predicate, and then it only say that there is an object that satisfies it if you specifically say that there is one. That's how we've been working through this. So because for this to be true, for RAB to be true, given that A is 0 and B is 1, I'd need something to appear under R01, and because nothing appears under R01, that conjunct comes out as false, and the same thing for the other one. So that's how we got there. Okay? Good. Okay. Let's take a break, take 10 minutes, and we'll come back and do more examples of this stuff. So once again, let's do this invalidity, and we're going to do the invalidity by doing an expansion. This time we have to expand both the premise and the conclusion because they both contain quantifiers, but that shouldn't give us too much trouble. So let's say our universe of discourse has 2 objects, 0 and 1. Okay, so expanding the premise 1 first, universal expands into a conjunction where we replace all instances of the variable with the number. So f0a, if and only if, g 0b, and f1a, if and only if, g 1b. Okay, that was an easy one because there was only one quantifier in that sentence. So to make that sentence true, of course, we're going to have to make both sides of it true. But let's expand the conclusion first, and then we'll have everything we need, and we can do our little chart where we decide what's true and what's false. So expanding the conclusion, we got two existentials, so it's going to end up being a series of conjunctions. Just mark myself, that's premise one. Here's the conclusion. So starting from the outside in, we've got there exists a y such that f0y and g0y, bracket, or there exists a y such that f1y, f1y and g1y. Okay, close brackets. Okay, so we've done one of our existential quantifiers. Now it's time to expand the other existential quantifiers. This disjunction is going to remain the main connective of the sentence. So we're going to expand these from within. So starting from the left, we're going to expand this into all of the objects in the universe of discourse. So first, we've got f00 and g00, or f01 and g01. Okay? So that's this first thing expanded. And then, or, well, now we're going to expand the second thing. f10 and g10, or f11 and g11. Okay. So now we've expanded our premise, we've expanded our conclusion, and the goal, as always, is just going to be to make the premise true and the conclusion false. And go ahead and erase this intermediate step just so that it's clear what's going on. Hopefully not erase anything else. Okay. Okay, so now all we have to do is decide what goes in our F predicate and our G predicate, and decide what the names A and B apply to. So we've got F00, F01, F10, F11, G00, G01, G10, G11. Okay. Made myself a nice little chart. And of course, we're going to decide what A and B apply to. Okay. So, I don't know. What do you say? A is 0, B is 1. Let's try it. Let's try it. So, A is 0, B is 1, meaning that this thing now says F00 biconditional G01 and F10 biconditional G11. Okay. So we need to make both of those things true in order for the premise to be true. once again, currently, these are biconditionals, meaning that if both sides are false, the whole thing comes out as true. So cool, it's just automatically true. Once again, let's just visually simplify a little. Okay, so the premise one comes out as automatically true, right? Because there's nothing in the F predicate at all, there's nothing in the G predicate at all. So F00 is false, G01 is false, and, F10 is false, and G11 is false. Great. So we don't have to do anything. We do have to do something, however, to make the conclusion false. Do we? Wait a minute. No, we don't. No, we don't. Nah. It's just a conjunction. It's just a series of disjunctions. And how do you make all of those disjunctions true? Don't do anything. Huh. I am genuinely surprised to see that, because when I worked this out, I didn't do the expansion. So I had a more elaborate answer to this. Yeah. I had an answer that applied properties to this thing. But as far as I can tell, we're good. That's it. We're done. I didn't mean that to be a tricky answer. I just didn't do the expansion before. Let's try this. So, yeah, these are two existentials. They all expand to disjunctions. We've currently said nothing satisfies any of these, like these predicates aren't satisfied. So, yeah. Hooray. We've solved it. So here's our invalidity. F contains no objects. G contains no objects. A is 0 and B is 1. Ta-da! Well, that was much easier than I expected. So here's the answer that I had written down. I had written down F01 is true and G00 is true. So premise 1 still comes out as trivially true on this account. So because nothing satisfies F00 and nothing satisfies G01, that's fine. And nothing satisfies F10 and nothing satisfies G11. So that comes out as true, so fine. Now, F01 comes out as true, but not G01, so this conjunction is false. This one's false, this one's false. F10 and G10 is also false, and F11, G11 are also false. So this would have also been a correct answer, but we didn't need to write anything in any bracket here. It just came out as trivially true. By applying no object, by saying that these predicates apply to nothing, it just comes out as true. So a good argument for doing the expansion, which I apparently had not done before. Yeah? Okay, questions? Yeah?
Does that mean your premise is true and the conclusion is false?
That's right, yeah.
So it's invalid?
It's invalid. Yeah, which was the goal was to show that this argument is invalid, and by having done nothing, we have accomplished that goal. Yeah. Yeah, my favorite kind of goal, where you just hang around. You had to figure out that you could do nothing. I mean, it's not that you didn't have to do any work to get there. And if I ask you for the expansion on the exam, you have to write out the expansion part of it. So it's not like there's zero work. But we didn't have to say that anything, so we could have just happily left the set of things that F applies to and the set of things that G applies to empty, and still would have shown that this argument is invalid. Yeah?
What is a P1 C overlap?
Oh, this is just me marking, this is premise 1 and conclusion. Yeah. Yeah. Okay, shall we do another? Hopefully one that involves more. I don't know if you hope that it involves more, but all right. So, we got some expanding to do. We've got some expanding to do. So let us expand. Let's say, once again, let's call it a universe of discourse with two objects. That seems to be working out pretty well for us. So, UD containing 0 and 1. All right, let's expand premise 1. So, there exists a y such that, whoops, stop that, will you? Okay. So, there exists a y such that f(0y), or there exists a y such that f(1y). Now expand that again to f(0,0) or f(0,1), or, so that's this one, and we'll do this one, f(1,0) or f(1,1). Okay. Okay with that? It's an informal notation, but it's just a bunch of disjunctions, so good to go. Reasonably satisfied? So to make that true, we just have to come up with one thing that we just have to satisfy one of those things. Okay, that's premise 1. Let's do premise 2. I'm going to continue to erase these things just so that we have a simpler visual field. Okay, so P1 that we're going to try to make true. P2, let's try to make P true true. Okay, so this is an ill-formed sentence. This is an ill-formed sentence. Uh-oh. Uh-oh. I've clearly written this down wrong. Ah, okay. My mistake. There's supposed to be a bracket there. Okay. Now we can meaningfully expand this thing. Apologies. Yeah? Okay. So, now it's the universally quantified. It wasn't clear whether the scope of this universal was the whole sentence or just this sub-sentence. So that's why we needed to know where the bracket went. Anyway, so expanding this into a series of conjunctions, we have there exists an x such that f(0), or sorry, f(x)(0), then for all x, f(x)(0), and there exists an x such that if there exists an x such that f(x)(1), then for all x, f(x)(1). Okay, now let's make brackets curly. Yeah? Okay, and we'll just sort of expand these things one at a time. So expanding, so you got to pay attention to where the major connective is. So we're going to expand just this thing. Just this thing. So there exists an x such as f(x)(0), and it's going to be then this expanded conditional this expanded. So this is going to take some work. So f(0,0) or f(1,0). So that's our this thing expanded. Then should I just go ahead and expand this universal in this step? I'm going to just go ahead and expand this universal right now. This was fairly straightforward. So expanding this universal, we're going to say f(0,0) and F10. And. Okay, so now we've expanded all of this stuff. And now we're ready to expand all of this stuff in exactly the same way. So F01 or F11 bracket then, and then we'll expand this thing, F01 and brackets here, F11. Okay. Whew. Right. And now let's expand this. So that's premise 2 expanded. So we don't need to think about this anymore. Got this all taken care of. Oh my. Okay. So there's premise 2 expanded. Now let's expand the conclusion. For all x, f(x)(x). So that says either f(0,0), sorry, it says f(0,0) and f(11). Yeah? Okay. Right. So now we need to figure out what our universe of discourse. So now we've done the expansion part. We're ready to move to using this expansion to demonstrate invalidity. The nice thing about this one is that there's only one predicate we're dealing with. It's just the f predicate. So we need to figure out whether f(0,0) is true, f(0,1) is true, f(11) is true, and f(10) is true. So myself a nice little chart. A fairly limited number of options, though, which is nice. Okay. So I'll just wait 1 second. I still see a number of people writing, so I'll just wait 1 second for you to catch up. Think about where we're going to get here. So we need to make premise 1 and premise 2 both true and the conclusion false. Making premise 1 true is going to be easy. We just have to put something. What premise 1 tells us is there's got to be something under some of these. So let's not worry about premise 1 just yet, because if we do anything to make this true or this false, then we're good. And the conclusion is going to be easy to make false. All we need is either one of these to be false. So we either need this to be false or this to be false. So really, premise 2 is where the challenging bit is going to be. And we need to figure out a way to make premise 2 true. Okay, so premise 2 is the major connective is a conjunction, meaning we have to make both this line and this line true. Okay, so each one of these is a conditional. Of course, you'll be tempted to say, one way to make this conditional true is, of course, to make the antecedent false. So if 0,0 or F10 is, if these are both false, then the whole conditional comes out as true. Currently, yeah, that's fine. This is false and this is false, so good. However, we still need to make one of these true. We got to pick one of these to make true. Should we just pick one and see what happens? Let's just pick one and see what happens. So let's make F(0,1) true. Just try it, see what happens. So now, this is still trivially true, right? So F(0,0) and F(10) are both true. So this half comes out as true. Now we've got F(10) or F(11) as the antecedent. So we've got F(10). So the antecedent is true. To make this conditional come out as true, we need this whole thing to be true. So we need this half to be true, and it's a conjunction, so we need both of these to be true. So currently F(10) is true, that's fine. If we just make F(11) true, then I think we might have done it. So Okay, let's review. Premise 1 is true because at least one of these things is true. In fact, two of them are true. It's doubly true, which is just true. Okay. Now, we need premise 2 to be true, and we made premise 2 true by making this half of the conjunction trivially true. So it's, this half of, this conditional is true because F00 is false and F10 is false. F00 is false, F10 is false, so this thing comes out as true. We made this true because F11 is true, so the antecedent comes out as true. We need the consequent to be true as well. Well, it is. F10 is true, F11 is true. Good. So premise 2 is true. What makes the conclusion false is, so F11 is true, but that's okay because F00 is false, making the conjunction false. So we did it. So here's our answer. The ordered pair 0 and 1, and the ordered pair 1, 1. Ta-da. There, we've demonstrated the invalidity of this argument. Yes?
Would it also work if we only made F10 true?
Let's try it. I can't, off the top of my head, I can't tell, so let's try it. Okay, so what do we got now? Premise 1 is still true because at least one of these things is true. F10, so that makes this antecedent true, but this consequent false. Yeah, so that's not going to work because we need this to be true. Could we have made this thing true? Well, maybe we make F00 true and F10 true. So now this conjunct is true. F01, F11 are both false. So this is trivially true. And this still comes out as false. So it would have worked if we'd said instead, so here's another equally good answer. Ordered pair of 0, 0 and ordered pair 1, 0. An equally good answer. Any questions? Yeah.
Are all the invalidities that we do going to be expansions, or?
I think I'm going to make you do one. So I'll give you one or two where I don't require expansions, but you've always got this if you've got this skill and you're stuck on the invalidity, like this is how I solve invalidities. I do the expansion so that I have it all in front of me. So if you're stuck on an invalidity where I don't require the expansion, feel free to do the expansion to get a solution for yourself if you find it helps. But yeah, so I think the plan is to do 2 or 3 that are just requiring to give the answer to the invalidity, and then 2 or 3 that are expansions plus invalidity. That's the plan. Yeah. I'm handing in the final version of the exam this afternoon. So these questions will be determined very soon. Very soon. Yeah. And then in class this is the last skill, by the way, this is the last skill of the course. We'll still have a class on Wednesday, but it's just going to be talking about the structure of the exam and minor review. That's all. I have nothing new planned for Wednesday, just review and talking about what's going to be on the exam and what exactly it'll look like and how to approach it and all that kind of stuff. Yeah? Want to do one more? Okay, let's do another. Whew. All right. Oh, good. Okay, well, this is the last one I have, so. Okay. Oh, man. These things are a lot of manual labor. Like, you're really turning the crank on these things. Okay. I'm sure I would not have done it to myself that I need a universe of discourse of more than 2 objects. I would never be so cruel to myself. I'm very nice to me. Okay, so let's do the expansion, premise 1. So there exists a y such that AZ R ZY if and only if GX and, oh boy, G0 and R Z0. And there exists a y, AZ, R, brackets around it, ZY, if and only if, G1, and R, Z1. Just on the edge of the screen there. There we go. Okay. Whew. Now it's a matter of organizing our page in some way that helps us remember what the heck is going on. So I'm going to have to do 2 more expansions on both sides of this thing. So it's going to end up big. There's going to be a lot of parts of this. Nonetheless, we can do it. We're just going to do it one bit at a time. Turn the crank. Do it systematically, and don't freak out. It'll be fine. So this is me talking to myself right now. Okay. Okay. So all right. Now we're going to expand this existential. So for all z, if R Z0, if and only if G0 and R Z0, or for all Z R Z1, if and only if G0 and R Z0. Okay, so that's this thing. We say and, now I'll expand this existential. Z R Z0, if and only if G1 and R Z1, or for all Z R Z1, if and only if G1 and R Z1, no, yeah, Z1. Okay. So we're going to expand these 4 conjuncts, disjuncts, well, a mix of conjuncts and disjuncts, into 8, because we're going to have to expand this one last time. Okay, deep breath. You do it. Don't succumb to math panic. This is the most math panicky thing I've ever done to you, because there's a lot of numbers and letters flying around. It'll be okay. All right, we're just going to do this one thing at a time. So, expanding this thing. R 0, 0, if and only if G0 and R 0, 0. So this whole thing and R 1, 0, if and only if G0 and R 1, 0. Okay. Or, okay, so this is the thing we're expanding. Here's the original. Here's the first round expansion. Here's third round expansion. So we've expanded this thing, and then we've got or. Now we're going to expand this thing. R 0, 1, if and only if G0 and R 0, 0. Yeah? Sorry, there should be more brackets there. Okay. And R 1, 1, if and only if G0 and R 1, 0. All right, yeah, we're expanding this thing now. So R 1, 1, yeah, that should be right. Is that right? So this is the expansion. This is the expansion of the first one, or this is the expansion of the second one. I'm just going to double check. Not a terrible idea that I did this right. Okay, so replacing the Z for 0 first, 0, 1, and G0 and 0, 0, and then replacing it with 1, 1, 1, therefore 1, 0. Okay, so far so good. So we got this whole thing in a conjunction with, now we're going to do this thing, and then we will have expanded it. Okay. So we're on this one. So R 0, 0, if and only if G1 and R 0, 1. And R 1, 0, if and only if G1 and R 1, 1. Ooh boy, okay. Okay, so now we've expanded this thing. Now we're going to expand this thing. So we say or R 0, 1, if and only if G1 and R 0, 1. And R 1, 1, if and only if G1 and R 1, 1. Whew, okay. Easy, right? Okay. Okay. Okay, we've done our expansion anyway. We've expanded premise 1. So good. Isn't that much clearer and simpler now? It's just so, it just should jump out at you as obvious what's going on and how it works and everything's cool and easy. Great. Okay, I'm just going to erase all this stuff. We don't need any of that now. Okay. So here's our premise 1. It's our only premise, so it's our premise. Okay, now let's expand the conclusion. And then we can do our invalidity, and then we will definitely be calling it a day after that. So I'm going to expand the conclusion up here if you don't mind. So there exists an X such that a Y, that means we can do a disjunction. So for all Y, if R Y0, if and only if GY, or for all Y, R Y1, if and only if GY. Okay, I'll just expand these. That needs a bracket. We'll just expand these, and we'll have our conclusion expanded. So R 0, 0, if and only if G0. So this thing and R 1, 0, if and only if G1. Okay? So all this is our expansion of the first half here. We say or R 0, 1, if and only if G0 and R11, if and only if G1. Bracket, bracket. Okay. Right. So the thing to do now is, of course, we've got two relations. One of them is a two-place, one of them is a one-place. So we just need to figure out is G0, is G1, and is R00, R01, R10, R11. So now we just have to figure out what we're going to stick in here to make the premise 1 true and the conclusion false. Yeah? Okay, once again, visually simplifying if possible. Okay. So keeping track of the major connectives is probably the tricky bit here. But you can remind yourself what the major connective is. Here's the easy way. So with this premise 1, like, oh, what the heck was my major connective? I cannot remember. Well, here's the rule. If it starts with a universal, in the final expansion, the major connective is going to be a conjunction. If it starts with an existential, in the final expansion, the major connective is going to be a disjunction. Okay? So because we've got a universal out front in premise 1, we know that this whole thing is going to end up as a conjunction. And this is our major connective. Yeah? Is that clear? So to make premise 1 true, we need to make these two lines true and these two lines true, somehow. Okay, let's just get into this. So let's just focus on this thing. Wow, I wish I had better handwriting. I bet you wish I had better handwriting too. Okay, so we need to make both of these things true somehow. And these are all, so, sorry, it's this thing or this thing. So this set of conjuncts or this set of conjuncts, we just have to pick one of them to make them true. And to make one of these, so either this line or this line true, I need to make this and this true, right? So let's just start with the first one and make it true. Oh, it's a biconditional. Oh yeah, hooray. Love biconditionals because they're just easily true. So R00, biconditional, and of course we get our biconditional favoritism. If and only if G0 and R00, well, cool. Automatically true. Same thing with this one. Okay, so what we've got here is trivially true premise 1. We didn't have to do anything to make premise 1 true. Yeah? But we do have to make the conclusion false somehow. And to make a disjunction false, you have to make both sides of the disjunction false. So we have to do something to make both of these false. And then we check to see whether it messed up our work on premise 1. Okay, so we need to make this conjunct false, which means we need to make at least one of these things false. So R00 biconditional G0. Well, let's make G0 true. Let's try it. Okay. So we made G0 true, but not R00, which means this biconditional is now false, which means this conjunction is now false. So this half is false. Cool. G0 is false while R01 is false, meaning this biconditional is false, meaning this conjunction is false. This whole conjunction is false. So cool. We just made the conclusion false by just making G0 true. Yeah? Okay. Now, what have we done to premise 1? Have we messed up premise 1 for ourselves? And if so, can we fix it? So, going back to premise 1. We need to make this true, we need this whole block to be true, these two lines, and this whole block to be true. So G0 biconditional R0, 0. So this is true now, but this conjunction remains false, right? This conjunction remains false. So this remains trivially true. Good. And this conjunction remains false, so this remains trivially true. Good. So that means that this whole line is true, and to make this whole block true, these two lines true, because they're connected with a disjunction, given that this whole thing is true, that makes this whole block true. So far, so good. Now, is this whole thing true? G0 doesn't actually appear in here. So have we done it? Did that do it? Might have done. So G0 does not appear anywhere in this whole block. This is all about G1. So that means that these biconditionals will all come out as trivially true because we haven't applied these predicates to anything. So I think we did it by just making G0 true. I once again had a more elaborate answer, but it seems like it works. Yeah?
I don't think you needed the 1 in your universe in this case. You just did it with the 0 and same thing, just G0.
Yeah.
I think that was still wrong.
Wow, that would have saved me a lot of time. Yeah. Yeah. Okay. This is from Logic 2010, so we can test these answers out. So this is one of the invalidity. I think this is 4.003. It's not one of the ones I assigned, but so we can test these answers out. I'm going to go back to my office and see whether this is a valid answer, and we can test whether it also works with 0 objects. Okay. Any quick questions before we're done? Okay, that's it. Thanks, everyone.